All right, let's pull back the curtain on one of Python's most powerful and, frankly, coolest tools. We're going to uncover the secret that makes dictionaries so insanely fast and find out why they're an absolute favorite for so many developers.
So picture this. You've got a database with millions of user profiles, and you need to find one, just one, specific person by their username. You're not going to check every single user one by one, right? I mean, that would take forever. So how in the world can a program find that one user in the blink of an eye?
Well, the answer to that puzzle is this beautiful and powerful data structure right here. The Python dictionary is the tool that makes these split-second lookups a reality. But how? How does it actually pull off this feat?
It really can feel like a magic trick. You give it a key, and bam, it instantly hands you back the value you're looking for. To really get it, we first need to make sure we're all on the same page about what a dictionary actually is.
At its most basic level, a dictionary is just a collection of key-value pairs. And, the analogy to a real dictionary is just perfect. The word you look up is the key, and the definition you find is the value. In code, this means you can use some unique key to get directly to its data, no searching needed.
Okay, so it's time to go behind the curtain. Because the magic, well, it isn't really magic at all. It's just a really, really brilliant piece of computer science.
The dictionary's real secret weapon is a data structure called a hash table. This is the engine that's powering that incredible speed. Instead of storing things in a long line, a hash table organizes them in a way that makes finding things almost immediate.
Okay, this is where it gets really cool. Here's how it works. When you add an item, the key, let's say it's the word major, gets fed into something called a hash function. Now this function is like a super efficient sorting hat. It instantly calculates a specific address in memory, a storage location, just for that key. Then the value, CS, gets stored right there. So when you want to find major again, Python doesn't search for it. It just runs the hash function again, which gives it the exact same address, and it goes straight there. No fuss, no searching.
So we keep saying fast, incredibly fast, but how do we actually talk about this speed in a standardized way? Well, programmers use a language called Big O notation. It's pretty much how we measure and compare how efficient an algorithm is.
Let's just compare two huge concepts here. On one hand, you've got ON, or linear time. This is like searching for a book by checking every single title on the shelf. The more books you have, the longer it's going to take. Simple as that. But then on the other hand, you have O1, or constant time. This is the dictionary's secret sauce. It's like knowing the exact shelf and the exact spot where your book is. It doesn't matter if there are 100 books or a million, the time to find it is always the same. It's constant.
And wow, this chart just says it all, doesn't it? Look at this. Searching through a list, that's ON. The time just skyrockets as the list gets bigger. That's why that bar is so tall. But a dictionary lookup, our O1 hero, stays flat and ridiculously fast, no matter how much data you throw at it. That tiny little bar, that is why dictionaries are so loved for lookups.
Okay, so we've seen the massive speed difference. Now let's kind of put this under a magnifying glass and see how it applies to the specific dictionary operations you're probably using every single day.
Because of this whole hashing thing, a bunch of the most common operations you do perform in that amazing O of 1 or constant time. On average, they're just blazing fast.
Think about it. Adding a new key value pair? Bam, it's instant. Deleting one? Poof, it's gone. Fetching a value using its key? Here you go. Even just checking if a key exists in the first place, it's all practically instantaneous. Python just hashes the key and goes right to the spot. No searching required.
But, and this is an important but, not everything is constant time. Sometimes you need to do things that even hashing can't speed up, and these operations fall into that other category, O of n.
It just makes sense, right? If your goal is to look at every single item in the dictionary, like if you're looping through all its keys and values, then there's no magic shortcut. You have to visit each of the n items one by one, and so the time it takes will grow in a straight line with the size of the dictionary.
So here's a super handy cheat sheet to kind of lock this all in. Getting, setting, or deleting an item using its key, O1 on average, fast. Looping through the whole shebang, ON, slower because you have to visit everything. This is a great little table to keep in the back of your mind.
Okay, let's bring it all home. What does this all mean for you when you're sitting down to write some code? Let's put it all together.
I love this summary. It perfectly nails the whole idea, you know? A dictionary is all about using keys, which are processed through hashing, all to achieve one goal: incredibly fast access to your data.
So here's the bottom line, the thing you absolutely need to remember. Whenever your problem involves storing data that you'll need to get back quickly using some kind of unique identifier, the dictionary should be the first tool you reach for. It's built for speed.
And that brings us to a final thought. Dictionaries are the absolute champions of the fast lookup, no question. But their power is all based on the key, not on position. So, what happens when the sequence of your data actually matters? What if you need it to stay in a specific order? Well, that's a question for a different data structure, and hey, maybe another explainer. Thanks for tuning in.